Our meeting today, I will continue the friction phenomenon. Last time I told you if you have a box on horizontal plane, this box has a weight W. Any weight is vertical in a vertical direction. If you are trying to push this box to right with a force, then I can expect that there is a friction force opposite to the direction of the applied force. And this friction force equal mu time N. Mu called friction factor or friction coefficient. N is the normal force perpendicular to the contact surface. Contact surface between this box and this surface. So we have horizontal surface, so the normal force perpendicular to this surface will be W. Let me explain it in more details or in a different way. Guys, can you watch for each force in this system? We have applied force, we have friction force, we have weight or normal force. The applied force parallel to this surface. The friction force parallel to this this surface. The normal force perpendicular to this surface. So we have a horizontal surface. Everything is related to the surface. Sometimes parallel, sometimes perpendicular. We don't have any other forces. All forces you have one of two cases, parallel or perpendicular to this surface of contact. What will happen if you have inclined surface? Inclined surface with angle theta. Before anything, can you tell me what is the direction of the weight of this box? At the centroid, at the center of mass, we have a vertical force to down, equal W. Weight. I have a question. Do you think this weight in this position or in this direction will be okay for this inclined surface? No. Your forces must be parallel or perpendicular to the inclined surface. So we need to do some adjustment. Hey, before in the previous modules starting for this semester, we have inclined force. And we need to get the component for this inclined force to horizontal component and the vertical component. Yeah, that makes sense. But right now, we have a different scenario. We have a vertical force, which is good, but we need to get there. This component and this component. This one is parallel to the surface. And this one in perpendicular to the surface. So does that make sense? I know the force is a vertical force. It's good, but we need to construct new axes. This direction and this direction. One of you will ask me why. The answer is very simple, because you have inclined surface and you have a body. We need to break any forces on this body to be parallel and perpendicular to the surface. So right now we have a vertical force W. I need to get this component of W and this component of W. That makes sense? Guys, that makes sense for you? Do you have any question for this point? If you have any question, let me know. Yeah, this one is tough a little bit, but it's very easy. Don't worry. Okay, so if you have inclined force, please go ahead and draw an axis in this direction parallel to this surface, and another one perpendicular to this surface. This angle theta, I believe this one will be theta. Do you know why? Okay, I can explain it to you. This angle theta equal to this angle theta. This one plus this one is 90. This one plus this one is 90. So this one will be theta. That makes sense? Okay. Okay. So this component of the weight will be W cosine theta. And this component of the weight will be W sine theta. I have another question. Which component of the weight, this one or this one, would like to push this box to be moved? I believe this component would like to push this box to down. So I expect here, opposite to this direction, I expect another force which is called friction force. Okay, now I need to explain something for you. When we are kids, if you have inclined surface and you put your toys or a box on this inclined surface, we found this box sliding to down. Which force? I didn't push this box, but because this surface is inclined, this box slided. Why? I need to explain it to you today. Because this box has a vertical weight. This vertical weight is broken to two components. One parallel to this surface and the other one perpendicular. So if this angle theta, this one will be theta. So this component will be W cosine and this component is W sine. So guys, we have a component of the weight in this direction equal W sine theta. This component is pushing this box to down. So we expect moving or movement to this direction. So we expect sliding. But we have here in the opposite direction at this surface, we have friction force. This friction force equal mu time n. I understand what is the meaning of nu. What is the value of n? Do you remember the meaning of n? A force perpendicular to the surface. Which force perpendicular to this surface? I think we have a component here equal W cosine. So N will be W cosine theta. So friction at the end equal mu times W times cosine theta. The applied force, which is trying to push this box to down, is this component, W sine theta. Can you remind me, this box will slide or not? Depend on what? The relationship between this friction force and this applied force. If the applied force greater than the friction force, we can expect sliding. Or if the friction force greater than the applied force, we don't expect sliding, we expect static equilibrium. Nothing will happen. Any question? Any question? So I'm talking right now about a box rested on inclined surface. This box has a weight. This weight will be broken to two components, one perpendicular to the surface and the other one parallel, using the inclined angle theta. The component parallel to this surface is trying to push. So we expect friction opposite to this pushing force. The friction force equal mu times n. N is the force perpendicular to the surface. Which force perpendicular to this surface is this component of the weight, W cosine. Okay, so if you have inclined surface, we need to do some adjustment to the problem before starting. Let me do this example. We have a crate or box with weight. This box has a weight. Weight means vertical to down. Vertical. 8,000 Newton. And the coefficient of static friction between the crate and the surface is 0.4. Coefficient or friction coefficient or coefficient of friction called mu equal 0.4. Determine the tension force in the cable. I connect this box to a cable, and this cable is connected to this tractor, because I expect sliding will happen. This box will be slided down. So I connected this box with a tie or a cable connected to this tractor. Can you tell me what is the force in this cable? I have a force here. I expect that I have a force here. I will call it T. I'm looking for what is the value of this force to make sure this box will not be slided. So determine the tension force in the cable connected between the crate and the tractor to maintain equilibrium. Equilibrium means no down movement for the crate. Let's start. Guys, I think the surface is inclined with angle theta equal 20. So I believe everything in this on this box must be perpendicular and parallel to this surface. I think this angle theta, which is the inclined angle for this surface, which equal 20, will be the same value between the weight and this axis, 20. So the weight 8,000 will be broken to a component in this direction will be 8,000 cosine 20. And we have another component here, 8,000 sine 20. One more question. If we don't have T here, if we don't have a cable, if you don't have a cable, this box will be slided or will slide down. So the friction will be in this direction. Friction force. Can you tell me what is the value of this friction? Equal mu time n. The mu is given 0.4. Any force perpendicular to this surface. What is the force perpendicular to this surface? This component, 8,000 cosine 20. So the friction force will be 0.4 times 8,000 times cosine 20. This value will be 3,007 Newton. So guys, which force pushing this box to down? Can you tell me? Can you look to these forces and tell me which forces trying to push this box to down? 8,000 sine 20. This component trying to push this box to down. Another question. Which forces support this? Which forces support this box? Which forces are supporting this box? This tension or this cable. So we have T. What else? We have friction. This friction force trying to support this box from sliding. So we have 3,007. When you expect equilibrium, if the pushing force equal the supporting force. So T plus 3,007 equal 8,000 sine 20. The only unknown in this equation is T, which is the tension force required in this cable to maintain equilibrium. this value of T equal negative 270 Newton. I have question. I got negative value. What is the meaning of this negative value? I need answer. And if you answer it correctly, I will give you 5 points in the coming exam. What is the meaning of force T equal negative value? What does it mean? Okay, Mitchell, I will explain what is which one is sine and which one is cosine just a second. I set up my forces, and by the end of the problem, I found T equal negative value. What does it mean? T negative value means I assumed the wrong direction. So T will not be in this direction, to up, like this. So what is the meaning behind this conclusion? What is the meaning behind this conclusion? I know if you got a negative value, you assumed the wrong direction. That makes sense. Okay, so I assumed the T in this direction to support this box, and I found the value of this T is negative. That means T should be in this direction. Doesn't make any sense to me, because if the tractor trying to support this crate or this box, I expect tension. I expect this tractor is trying to pull this box. What is the meaning of T in this direction? Thank you, Mitchell. Yes. Mitchell, extra 5 points. Exam 3. That means no need to this tractor. That means if you have this inclined surface with angle theta equal 20, and this box with weight 8,000 Newton, no need to this cable attached to this tractor to support this crane. No need. That means if you get 8,000 sine 20 and 8,000 cosine 20, and you have friction here, this friction is enough. This friction alone is enough to prevent this box from sliding, because this value is 2,700 and this value is 3,007. That makes sense. So the applied force, which is 2,700, trying to push this box to down, is smaller than the friction force, which equals 3,007 Newton. That means I don't need any other support. I don't need this cable to be attached to this tractor. This is the meaning of negative value. So, determine the tension force in the cable connected between the crate and the tractor to maintain equilibrium. This tension force must be 0. I don't need it, because I already have equilibrium without this cable. This is the meaning. I will do more example, but let me explain. Mitchell, I have inclined surface with angle theta. And I have vertical force here, 8,000, for example. And I need to break this force to two components, one parallel to this surface and one perpendicular. That's right. So what do you think if I said this angle theta equal to this angle theta? Do you agree? Z shape. So this angle equal to this one. Okay. This angle theta plus the adjacent angle are equal 90, because the angle between this red line and this red line is 90. So theta plus this little angle is 90. Do you agree? Also, this little angle plus this angle is 90 also. The angle between this green line and this green line is 90. So this one plus this one is 90. This one plus this one is 90. That means this one will be theta equal to this one, which is equal to this one. You got it? Okay. Okay. Let me do one more example. We have inclined surface with angle 20. And we have a box with our block with weight 1000 Newton. This weight is attached to this cable around this pulley and attached to a weight W. This W is unknown. Can you tell me what is the minimum value for the weight to maintain equilibrium? In a different way, I need to explain it separately. I have inclined surface 20, and we have block here. This block has a weight 1000 Newton. I will break this 1000 to two components, one parallel to the inclined surface and one component perpendicular. We have a given angle theta equal 20, will be the same value here, 20. So we have a component here of the weight will be 1000 sine 20, and we have a weight here will be 1000 cosine 20. And we have friction force here. What is the value of this friction force? Mu time n. Mu is given 0.3. N is the normal force perpendicular to this surface will be 1000 cosine 20. So the friction force will be 281.9 Newton. The applied force trying to push this block down is 1000 sine 20 equal 342 Newton. Do you expect sliding? Do you expect sliding? Here is the block. We have applied force here equal 342. We have friction here equal 281.9. We have normal force here equal 1000 cosine. 939. Anyway, do you expect sliding? Yes. Sliding will happen. So I'm trying to support this block with a cable around this pulley and supported and attached at the end by a weight. And I'm looking for what is the value of this weight to maintain equilibrium for this box or this block. Guys, just to remind you, do you remember if we have a pulley? You remember that? You have a pulley and you have a cable around this pulley. What is the meaning of that? Means if you have a weight here, W, this weight will be the same value here, W. If you have a force here, will be the same value, force. That makes sense? So I think we will have a force here, W. This force is trying to support this block. I believe the minimum value for this weight to maintain equilibrium for this block will be 342 Newton, which is trying to push, minus 281.9 trying to support. So the final value will be 60.1 Newton. I need at least 60.1 Newton here to be added to this friction force to support this block against this applied force. Does that make sense? Okay. I have a question. What will happen if you have angle here, if this force equal 300, for example, and this friction force equal 350 Newton. Can you tell me what is the minimum value for this weight to support this box from sliding? In this case, I'm assuming if the applied force trying to push this box to down equal 300 and the friction equal 350, can you tell me what is the minimum value for W here to maintain equilibrium? Thank you. I don't need any extra support. I don't need any weight here. I don't need any support here. Why? Because the friction force is enough. Does that make sense? For our problem, this is not happened because the friction equal 200 only, 81. But the applied force equal 342. So I expect a sliding. So I need extra support. So we need W equal 60.1. And that makes sense. Okay.